Alright, this is the intermediate 2 notes, probability, statistics, and data. Just to remind you how to find the average. Typically, unless it says a different type of average, average implies the mean. To find the mean, you sum up all the numbers and you divide by how many numbers you have. So first example. Over a 5-day period, the average high temperature for Cleveland was 30 degrees. If the high temperature recorded for the first 4 of those days were 26, 32, 24, and 35 degrees, what was the high temperature recorded on the 5th day? So once again, to find the mean, you sum up all the numbers and divide by how many numbers you have. We're told that the average high temperature was 30. We're told the number of days was 5. And we're told that one of those days was 26, another was 32, another was 24, another was 35, but we don't know the 5th day. So once again, we know that if we add up all the temperatures and divide by how many temperatures we have, we're going to get the average. We have 4 of the temperatures, we don't know the 5th. So this is the equation that we're going to use, and then we're trying to simplify this equation. If we were to add 26 and 32 and 24 and 35, we get 117. Trying to solve the equation for x, if we multiply both sides of the equation by 5, we get 150 equals 117 plus x. And if we subtract 117 from both sides, we're going to get that the temperature of the 5th day would be 33 degrees. Number 2, very similar. The average score of IV's basketball team for 4 games is 90. So mean equals sum of all the scores divided by the number of scores. 3 of those scores were 89, 92, and 94. What was the 4th score? So the average is 90. In the games, they scored 89, 92, and 94. We don't know how many they scored in the last game, so we'll call that x. It's an unknown, it's a variable. 4 games total. So, if we simplify this, 89 plus 92 plus 94 is 275. If we multiply both sides by 4, trying to get rid of this fraction, trying to get x by itself, we're going to get 360 equals 275 plus x. If we subtract 275 from both sides, we get that the 4th game must have been 85 points. I'll give you another way to look at this problem that may be faster than what we just did there. So we're going to set the bar here at 90. That's what we want to average. One of those games was in 89, which is just the one below. Another game was in 92, which is 2 above. So right now, we are 2 above and 1 below. So if we wanted to even this out, we need another one to be 1 below to average 90. The next game is a 94. So if you look at this one here, we are down 1. These two, we are up 6. We want those to be equal. So to be equal, we need to be down 5 more here. So down 5 below 90 would be an 85. It's another way to look at average if that's helpful. Maybe it is. Maybe it isn't. The average of 8 numbers is 9. So mean equals sum of all the numbers divided by how many numbers do we have. The average of the 8 numbers, mean, is 9. There are 8 numbers. We don't know what the sum is. If one of these numbers is removed from the group, the average of the remaining numbers is 7. So if we take a number out so that we only have 7 numbers, the average is 7, and we don't know what that sum is still. So what we can do is we can take this first equation we have, multiply both sides by 8, and we get 72 as the sum. We have all 8 numbers, the sum is 72. If we do the same thing for this other one here, multiply both sides by 7, we get the sum of 7 of the numbers is 49. So that must mean that the missing number is 72 minus 49, which is 23. So you can recheck that to make sure that it works. If we, well, there's no need to recheck it. Just reread the question. The average of 8 numbers is 9. So we're adding 8 numbers, average is 9. If 1 is removed, so now we have 7 numbers, the average of the remaining numbers is 7. What is the value of the number removed? Yeah, it's got to be 23. Probability of a single event. The probability of something happening is the number of favorable outcomes divided by the total number of outcomes. Example, a 6-sided die is tossed. What is the probability that you will get a number greater than 6? So probability of a number greater than 4. Well, how many outcomes are there greater than 4 on a die? There are 2. You can have a 5 or you can have a 6. You divide it by the total number of outcomes. There are 6 sides to a die, so the probability of getting something greater than a 4 is 1 out of 3, because 2 6 reduces to 1/3. Next we have the counting method. A litter, if you will, has 4 black and 5 white kittens. And how many ways can a pair of 1 black and 1 white kitten be chosen from this litter of kittens? So here's how the counting method works. We got 2 choices. We're going to multiply those 2 choices together. So we have 4 black cats to choose from. So how many choices do we have? We have 4. Could be any one of those 4. We have 5 white kittens to choose from in this scenario. Simply multiply those together, and that is how many ways pairs of kittens can be chosen. If one of them has to be black and one of them has to be white. 20 different ways. Another example. From a garden warfare, there are 6 different types of flowers. If a bouquet of 3 different types of flowers are to be chosen, how many different possible bouquets are possible? Notice it also says that 3 different types are going to be chosen. So once again, we're choosing 3. Before we were choosing 2 kittens, we are choosing 3 different types of flowers. Since there are 6 different types, when you choose this first flower, you have 6 to choose from. Now there are 5 different kinds of flowers remaining, because it says we need different types. You can't have the same type twice. When you get to the second choice, you're choosing one of the 5, so there's 5 choices. Once you remove that choice as a possibility, there are 4 choices left. Simply multiply those together. There is a possibility of 120 different bouquets possible. The addition principle of counting. This is better known as using a Venn diagram. Of a group of students at lunch, 9 ate pizza and 5 had salad. If 3 had both pizza and salad, how many ate, should be 8, not at, pizza, salad, or both pizza and salad? So we got the situation. We got this circle here of the students that had pizza. We have this group of students here that had salad. Now it says some of the students had pizza and salad. So that means that we can take this, we can kind of push these groups together. There's an overlap. People that are in the overlap here are the people that had pizza and salad both. So when you're doing this, start out with the ones that had both. 3 had both. So that's going to go here in the center. If 3 of them had both and 9 had pizza altogether, that must mean there has to be 6 here because 6 plus 3 is 9. 3 had salad. Of those, there were 5 total that had salad. 3 had both. That means there are 2 left here. So if you look, we got 5 had salad. We got 9 had pizza. 3 had both. So how many were there total that had pizza, salad, or both pizza and salad? Well, it's 6 plus 3 plus 2, which is 11 people. Venn diagram is very helpful for some problems, such as this next one. 2 circles are drawn using chalk on the black top. We'll assume they overlap. If they end up not overlapping, then we'll just put nothing in the middle. 20 girls are standing in the pink circle. Oh, better change this to pink. And 15 are in the blue circle. 9 are in both circles. So we got 9 here in the center. 20 are in the pink. 20 minus 9, which means there's 11 that are in the pink circle exclusively. It says 15 are in the blue, and 9 are already being shared. So that means 6 are in it exclusively. And the total number of girls standing in the 2 circles, so 11 plus 9 plus 6, that's 26 ladies. Here is a table. So read some data in the table. Always read the headings. Sporting trading cards that Albert collected over a 5-month period. So we got baseball, football, hockey, cricket, and rugby. And then we have different months and how many he's collecting in each month. So the question, how many baseball cards did Albert collect in March? So here's March. And then across the top is baseball. So looking at the baseball row in the March column, he collected 38 cards. How many rugby cards did he collect in May? Well, rugby is down here. May is the last column. Looks like he collected 1 rugby card in May. That's how to read a table. So here's a different kind of chart. It's a bar graph, histogram perhaps. Question is, approximate how many cards Albert collected in April. So April is here. Doesn't say what type of cards, so we're going to assume all of them. If you look across the top, this here is the number of cards collected as the vertical axis. So if you look here in April, it's someplace between 90 and 100. You couldn't say for certain, but we could probably approximate that it's around 95. Someplace between 90 and 100 for sure. Another type of graph is a line graph. Over a 5-month period again, number of cards collected. Which type of trading card did the number of cards collected increase from April to May? So the window we're looking at is here from April to May. If you look at this one here, which I think is baseball, it went down from April to May. Numbers got smaller. It went from like 45 to 40. If you look at the one that's got the square, which looks like football, it went from below 25 to about 25 from April to May. That one increased. So we're going to say that one's football. If you look at the other two, they all went down. Down, down, down. Red Knight going down. So we'll say football. Fewer cards were collected in February than January for how many types of trading cards? So it says fewer cards in February than January. So we want the number to be lower here and higher in January. Baseball went down for sure. So baseball. It went down in football. It went down in cricket. Who collects cricket cards? Is this Europe or what? And it went down in rugby. Also, come on, rugby. What year is it? The only one that went up was hockey. And it says which ones went down. So, all right, that's the conclusion of that. Please do exercise set 2.